This is the key to rational expressions, extra number 6. And basically you have these two problems, these two rational expressions. One you're adding, one you're subtracting. And so let's look at number 1. So number 1, you have x plus 5 divided by x squared plus 10x plus 16. And then you're adding that to 6 divided by x squared plus 4x minus 32. And so remember, before you can add or subtract rational expressions, the denominators have to be the same. And notice that those two denominators are not the same. So you got to factor first. So when I factor this, I'm going to get, let's see, that'll be x plus 8 times x plus 2. And here, let's see, that's going to be x plus 8, x minus, x minus 4. Okay, so that's what that becomes. So x plus 8 times x minus 4. Okay, now I'm going to rewrite this using the factored form. So always do that, so that way you don't mess up. So we have x plus 8, x plus 2 in this denominator, plus 6 divided by x plus 8, x minus 4. Okay, once you get it into factored form, you can easily determine the least common denominator. So your least common denominator must include every factor you see. So I see an x plus 8, I have to use it. I see an x plus 2, I have to use it. I see an x plus 8, I already have it. I see an x minus 4, I have to use it. So your least common denominator involves those three factors. So what I'm going to do now is I'm going to rewrite this, leaving some space. So I'm going to say x plus 5 divided by x plus 8 times x plus 2, leave some space, plus 6 divided by x plus 8 times x minus 4. Okay, now remember you still cannot add these because they don't have the same denominator. So now you're going to write equivalent fractions with this denominator, with the least common denominator. So x plus 8, x plus 2, x minus 4, plus, and then the same thing here, x plus 8, x plus 2, x minus 4. Okay, now you want to write, you want these two rational expressions to be equivalent. So this rational expression is equivalent to this rational expression with these factors though. So notice I have the x plus 8, I have the x plus 2, so I'm missing the x minus 4. So if I want to write equivalent fractions, then I've got to use x minus 4 as well. Now be careful, because this is a binomial, this is a binomial, you're multiplying those. So when you rewrite it, put the x plus 5 in parentheses. So say this, x plus 5, x minus 4. Okay? All right. And you know you're doing this correctly because when you reduce the x minus 4s right here, you're not going to do it. But if you were to, what you have left would be what you see here. And then let's look at this one. So this rational expression, you wanted an equivalent rational expression with these denominators though, with these factors. You have the x plus 8, you have the x minus 4, you're missing the x plus 2. So you're going to multiply this denominator x plus 2, and what you multiply the denominator by, you have to multiply the numerator by. And so now we're going to rewrite this numerator using this product, 6 times x plus 2. Okay, now at this point, what you may want to do is, now remember, always leave the denominator in factored form. Okay, leave it in factored form. Because remember, first of all, when adding two fractions, they have to have the same denominator. So now, if you want to, you can put this in one fraction, one rational expression. You want to leave the denominator factored. You want to leave the denominator factored because at some point you may be able to factor your numerator, and some of these factors may divide out. Okay? Now, you see this numerator? You got to multiply that out because that numerator is being added to this numerator. So you got to be able to combine like terms. So before you can combine like terms, you have to write each of these as individual terms. So if I follow this out, x times x is x squared. The outer is a negative 4x. The inner is a positive 5x. So I get a positive x. 5 times a negative 4 is a negative 20. Plus, distribute 6 here. I get 6x plus 12. Combining like terms, I get x squared. X and 6x is 7x. A negative 20 and a positive 12 is a negative 8. Divided by x plus 8, x plus 2, x minus 4. Now, at this point, you want to see if you can factor this numerator, and because if you can factor the numerator, it is possible that some of these factors can reduce, and that's what you want to be able to do. Your final answer must be as simplified as possible. So in the numerator, I can factor this as x plus 8 times x minus 1. That's this right here. The denominator is x plus 8, x plus 2, x minus 4. And then notice, remember we kept saying leave the denominators in factored form. Leave it in factored form because now you see that these factors divide out and your answer is x minus 1 divided by x plus 2 times x minus 4. Leave your denominator in factored form. Okay? So that's number 1. Number 2, we have, let's see, number 2. Number 2, we have this. All right, number 2, we have x minus 3 divided by x squared plus 6x plus 8, and then minus x minus 4 divided by x squared minus 4. Okay? All right, so let's go ahead and factor the denominators. So I get x plus 4, x plus 2. Over here, that's the difference of 2 squares. So I get x minus 2, x plus 2. And so now my least common denominator, well, let's go ahead and rewrite this over. So it'll be x minus 3 divided by x plus 4, x plus 2, minus, and then x minus 4 divided by x minus 2, x plus 2. All right. So the least common denominator now is going to be every factor you see. I see an x plus 4. I see an x plus 2. I see an x minus 2. And I see an x plus 2, which already happened. So it's those 3 factors. Okay, now let's go ahead and rewrite this over, but leave them some space. So I get x minus 3 divided by x plus 4, x plus 2, leave some space. Subtract, and be careful with subtraction. You gotta always be careful with subtraction. X minus 4 divided by x minus 2, x plus 2. Now what I'm going to do is I'm going to write 2 equivalent fractions, 2 equivalent rational expressions using this denominator. So x plus 4, x plus 2, x minus 2. Subtract, and then x again, x plus 4, x plus 2, x minus 2. Okay, now you're writing equivalent fractions. You want these two rational expressions to be equivalent. So if you notice, I have these 2 factors, right? But I'm missing this one. So if I'm going to make those equivalent, then I need this factor. So I need this x minus 2 here. But what I do to the denominator, I do to the numerator. Now, when you rewrite it, when you rewrite this here, you got to put this in parentheses because those are 2 binomials being multiplied together. X minus 3, x minus 2. Subtract. All right, let's talk about this one now. So this one, you have the x minus 2's, right? You have the x plus 2, but you're missing the x plus 4. So you're going to say times x plus 4 times x plus 4. Okay? And then notice, so be careful, this is a binomial times a binomial, so put that binomial in parentheses, just like this. Now, I would be a little bit careful here. So what I would do next is I would leave this as still as 2 rational expressions, but let's go ahead and FOIL this out, and then FOIL this out. In other words, and again, always remember, leave the denominators in factored form. Don't multiply those out, because at some point you may be able to reduce those factors. So if I FOIL this out, though, I get x squared. The out is a negative 2x. The inner is a negative 3x. I get a negative 5x. Negative 3 times negative 2 is a positive 6. Minus, over here, FOIL this out. X times x is x squared. The outer is 4x. The inner is a negative 4x. So the x term is 0. A negative 4 times a positive 4 is a negative 16. Divided by x plus 4, x plus 2, x minus 2. Okay, now listen carefully. See, this is subtractions. You got to be careful. So now I'm going to write this as one rational expression with this denominator. X plus 4, x plus 2, x minus 2. I'm going to get this. I'm going to rewrite this. Be careful when you subtract. So x squared minus 5x plus 6. And now you're subtracting all of this. So put that in parentheses, just like this. So I put this in parentheses. Now you're going to distribute the negative through here. So this becomes x squared minus 5x plus 6 minus x squared plus 16 divided by x plus 4, x plus 2, x minus 2. Combining like terms, the x squareds cancel out rather, and so I get a negative 5x, 6 and 16 is 22, divided by x plus 4, x plus 2, x minus 2. And there's nothing else I can do with the numerator. I cannot factor that like I could have factored this one. So I could have factored this, and I did. You have to. There's nothing else you can do. So this is your simplest form right here. Leave the denominator in factored form. So that's your simplest form. Okay, so that is the key to rational expressions extra number 6.